Hey guys, Simek here. I am gone today, so we're going to do a little lecture on climate and biodiversity. You should have your Chapter 7 reading guide out. And we're kind of going to start by talking about atmosphere in general. So we learned about lithosphere last unit. The atmosphere refers to that envelope of gases that surrounds Earth's surface. It's relatively thin if you're looking at like the crust plus the mantle plus the core, and then also when you're kind of looking at space. Okay, so when you talk layers, the one closest to us is called the troposphere. Okay, so now we're number 2. Then the stratosphere, mesosphere, thermosphere. I have more information on the next slide. This is kind of just a graphic. Okay, so starting with the innermost. Again, this is the troposphere. The really important thing about the troposphere is it's where all the weather happens. It's where all the weather happens. Okay, above the tropics, it's going to be about 11 miles above sea level. Above the poles, it's going to be about 7 miles. So it does change in terms of thickness. But whether we're at the tropics or the poles, we're looking at temperature, wind, and precipitation happening here. Okay. Next level is the stratosphere. 17 to 50 kilometers up. I know I just switched from miles to kilometers. Whoops. This is where the ozone layer is. Most commercial air travel takes place in the lower part of the stratosphere. We will talk ozone layer in spring. But this basically allows life to exist on Earth so UV radiation doesn't kill everything. The mesosphere, meso means middle. What you can write for this one is it gets much colder and meteors enter. And then the thermosphere is where the northern and southern lights occur. Aurora borealis, aurora australis. When they hit the magnetosphere, these solar flares, the region directly above the thermosphere, they pull these electrons from atoms and cause magnetic storms near the poles. So these red and green lights are seen when the scattered electrons reunite with atoms and return them to their original state. That is way more information than you have to know. I do want you to add exosphere. Exo means out or exit. As a last layer, all you really have to know is that it is, let's do blue, last. All right, so that should have answered number 2. Number 3 asks about the composition of the atmosphere. Why isn't, there we go. So most of it is nitrogen, which is an inert gas in its diatomic form. We breathe it in, we breathe it out. We breathe in that oxygen, we use it, and then we have kind of this mixture of other things, including water vapor, CO2, and methane. Okay, remember you can always pause me if I'm going too fast. And so when you look at what's going on in the atmosphere, we got to talk weather and we got to talk climate. Okay, weather is our short-term conditions. We talk, if you want to define it, if you want to write the definition, it is a set of physical conditions in the lower atmosphere. A set of physical conditions in the lower atmosphere. That includes temperature, it includes precipitation, it includes wind speed, it includes cloud cover. And when you're talking about time, we're talking hours, we're talking days. Okay, this is the weather that's happening. It's raining out. There's a hurricane, that kind of thing. When climate gets spoken about, we need decades of patterns. In fact, meteorologists say the period has to range from at least 3 decades to thousands of years. So if we're going to define it, it's the sum of weather conditions in an area, looking at a long time. Hi, Dan. So when people talk about climate change and talk about a single weather event, oh, it's so hot here, that can't be climate change. They're talking about weather. We need to look at decades and decades of data to talk about climate. So when air circulates in the lower atmosphere, Did I skip a slide? I skipped a slide. Sorry, homies. Dan brought home dinner, so I got distracted. All right, so here shows kind of some ocean currents. There's currents that bring nutrients from the bottom to the surface. Those are these upwelling zones that you see in the bottom. But when we kind of talk about wind, we also connect that to ocean currents, and then we talk about different biomes, kind of, which is what the next lecture is. We're in this kind of cool temperate area. There's this tropical area, okay? And so ocean currents can be described as these mass movements of surface water driven by winds blowing over oceans. Okay, they help determine regional climates, and they're a key component of Earth's natural capital. Like, they're really important. So we have these, basically it's caused by these prevailing winds, the Earth's rotation, heat that gets redistributed from the sun, and then you have these surface currents and these deep currents. And so what number 5 is asking is about air circulation that's going to cause these ocean currents to form. And it asks for 3 factors that determine how air circulates in the lower atmosphere. One of the big ones that I really want you to note, so this is 1, 2, 3, is this uneating of Earth's surface by the sun. Air is heated way more at the equator. The sun's rays directly strike the poles. They hit at an angle. We don't get as much sun at the poles. And so you have this uneven heating, which helps lend itself to this air circulation. The rotation of the Earth, the equator spins faster, if you know anything about physics, which I do not. But you can kind of picture that this moves these heated air masses that rise differently. And then just properties of air, water, and land, like in terms of their physical properties. Okay, so heat from the sun evaporates ocean water. Nothing gets evaporated from land. Dark land, like blacktop, absorbs heat. If you have snow, it reflects it back. And we're transferring heat from oceans to the atmosphere, especially near the equator. So here's what I want to make sure you have. This uneven heating of the Earth's surface by sun is probably the most important one. And then I want an example of this. So I'm just going to put write example. And I'm going to say the example right now. Here's what I want you to write. Warm air rises at the equator and sinks at 30 degrees. I'm talking latitude. Most deserts are located here because the humidity is lower. So this warm air rises. If you've ever been on a tropical vacation and like it rains every afternoon, that's why. Then it cools and sinks at 30 degrees, and that's where almost all the deserts are located because the humidity is lower. You might want to replay that if you didn't get it. I want you to circle number 6. You're going to do number 6 on your own. It talks about global circulation and convection cells, but let's talk Coriolis effect. Again, this is kind of a physics thing, so I sort of get it. There's a great video that when you go to the actual lecture that I shared that you should watch about Coriolis effect. But the idea is this perceived deflection when you look at something turning from a turning frame of reference. Okay? And the effects the Earth's rotation has on the movement of air and water. So basically, why do we care? Because it results in different directions of wind on Earth. Where's my picture? There should be a picture. No? Okay. So the trade winds, which you may have learned about in history, world history, maybe AP Euro, are these easterly winds that dominate the tropics and the subtropics. So this Coriolis effect results in wind directions. This is number 7. Again, remember that warm air rises at the equator and then falls. There's my picture. And so you have these, look in the northern hemisphere, you have this clockwise motion. In the southern hemisphere, you have this counterclockwise motion. So if you kind of look at a cross-section of the Earth, this is what we're going to see. You're going to see this warm air that rises. Then it kind of descends. Look at the 30 degrees. This is where our deserts are. And then as we move towards the poles, we get wetter again. Okay, so again, as air moves over the equator, it's heated, it rises, it moves towards poles, Earth's rotation deflects this movement of the air over different parts of the planet, and it creates these global patterns of prevailing winds that help distribute heat and moisture in the atmosphere. And then all these biomes listed, that's next lecture. What's a hot desert? There's cold deserts? Did you know there's cold deserts, Casey? He's got his headphones on. What? Did you know there's cold deserts? Yeah, like the Gobi with the Bactrian camel?
It looks like the sand is snow.
But it's not. Yeah. He says he knew that. All right, good. So this kind of shows the connected loop of deep and shallow ocean currents transferring warm and cool water. So these ocean currents are affected by winds in the atmosphere and heat from the ocean, which also affects circulation. The big concept here is wind and water currents are connected. All right, 8. Let's talk about El Nino. I have a good video for this too, but we're going to have to watch it when I get back. So this occurs every few years. It is a large-scale weather phenomenon, and it's where these prevailing winds change direction. Okay, so it affects a lot of the weather for like a year or two, especially in the land along the Pacific and Indian Oceans. So you have kind of this neutral setting. You have El Nino to one side and La Nina to the other side. And so it's El Nino Southern Oscillation can cause drought, it can cause increased rainfall, and it can cause increased warming periods. Again, I will show the video links when I get back. Let's do that together. Okay, so that's number 8. I gotta get this done before 15 minutes because YouTube will cut me off. 9 then looks at greenhouse gases. We have a whole unit on this, but the greenhouse effect is actually a really good thing. We wouldn't have liquid water without it. And so these gases like water vapor, carbon dioxide, what's CH4? You know what CH4 is? Cow farts. Methane. And then N2O, which is nitrous oxide. They absorb the solar radiation. So, right, the heat hits Earth and bounces back. There's this like blanket of gases that keeps the heat trapped inside, which keeps water liquid on our planet. So the problem is we're putting too many of these gases and the blanket's getting too thick. It's like sleeping under a fat comforter when it's like 90 degrees out. It's not good for the Earth. How are we doing that? Burning fossil fuels, we're clearing forests and all that kind of stuff. So that's unit 7. We spend an entire unit on global climate change. But the greenhouse effect on its own is not a bad thing at all. That was from last year, the polar vortex, because this lecture was like right after we missed 5 days of school. So the last thing I want to talk about is the rain shadow effect. If we're going to define it for number 10, it is the reduction of rainfall and loss of moisture from the leeward side of the mountain, which means like in this picture it's the east. The windward side is where the wind's coming from. And so the wind kind of like comes from the west, picks up water from the ocean. As it rises, it condenses. It gets all rainy, like Seattle. And then once it comes over the mountains, it gets all dry, like Las Vegas. So the air descends, it warms, it releases the little bit of moisture, and you kind of have like a little mini desert. So that should have gotten us through number 10. You're on your own for number 6. I will answer questions when I come back, and we will watch videos. Please be good for the sub. The end.